So we are recording again, and there was a question. Where did it go? Another question here. Where did it go? Okay. Yeah, here it is. So someone asked the question, I think Shawal asked the question, can I actually use, so I hope you are seeing it on my screen here. There is a question of, okay, can I use another array as part of initialization of a three-dimensional array, all right? A two-dimensional array. And my answer to that was, if you recall, we could not use any such thing in initialization. Initialization has to have constant numbers. You cannot have variables there. So that's very strict, at least on the version of the C that we are using. So some later versions have some flexibility in that, but the version that we are assuming, or we are using this very first ANSYS, the standard C, doesn't allow you to do this. But I can perhaps do something. So this would be, I think the need for this question is usually coming from the fact that, okay, this is very cumbersome, right? If I have this one and I want to actually repeat it twice or three times, can I actually do something else? Of course, what you could do is you could use things like, for example, this. You could use a define, let's say something like called blocked row, right? And you can say now in a 8x8 case, a blocked row could be something like, for example, if you recall, if I actually put this down here, I can simply do it this way. I can say, now a blocked row is actually something like this, 8 of them together. Okay, 1, 2, 3, 4, 5, 6, 7, and 8 of them together. So if I have this definition, then I can say, for example, here, if I want to do a definition void test, let's do a test case. And I have maze type. Where is my maze type? My maze, let's say MM. And this is num rows and num columns. Oops, easy. Num columns, all right, equal. Then I need 8 of those 8 blocked rows, right? So I can actually do it this way. I can say blocked row 1, then the second one, the third one, fourth one, fifth one, sixth one, seventh, and eighth one. I could, in principle, use this one. So what is going to happen is that define actually take this entire thing and just put it in place of that one. So this is a possibility. Or you might want to have, for example, just a blocked row perhaps for this one, and then maybe another row that, let's say, blocked row on left and right. Let's say right like this, on left and right. And you might say, okay, my row is actually blocked on the left and only on the left, not on the right, and on the right, sorry. And in between is empty. You could actually now say, okay, this guy is asking me to purchase something. So, and now say, okay, the first row is all blocked. The second row is actually just blocked on the left and right, and left and right blocked, left and right blocked, and left and right block here. The rest is going to be blocked row. So in this case, I will have an entry which all rows, first row is all blocked, and the rest of the 6 rows they have a blocked on the first column and a blocked on the second column, and then a last row that is fully blocked. So this could be my answer here for this particular thing. So it will make it a little bit easier. if you want to do it this way. So now let's go back to this thing. What I wanted to do was first make the maze all walls blocked. And then let's go back to this particular thing here that we want to actually do. If you recall, so now I have all of it is blocked, but I want to have, let's say, this row. I mean, I have this part is empty, this part is empty, this part is empty, and so forth. So how do I do it? Let's actually say that I want to actually fill this part here, this part here. This is not, this is empty. So which row is this? Answer me. Which row is this guy here? Which row? Answer. I'm waiting for an answer. Which row is this? Row 7. 0, 1, 2, 3, 4, 5, 6, 7. So if you are talking about one index, yeah, it is 7, but 0 index, it's going to be row 6, right? So it is 6. So which columns are they? So starting from 0, so this is 0. This is what this entry is going to be 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, and 6 and 7, no, 6. So if I want to fill this in, I can use a simple code segment like this. I can say, okay, for C from 1 to C is less than num columns, right? This is this one. From 1, this is 1, till less than 1 column. This is this guy gonna be this guy. Okay. Less than -1. And then I can now say, okay, increment this by doing this again. And then I say M sixth entry of this column, or the 6th row of each entry changing from 1st to 6th should be M free. You see, now what I did is I started my thing block first, everything, and then now I put this part, this entry. So if you want to do this a little bit, maybe this way, let's start. What I did is I'm gonna get rid of this part. And initially, I took everything to be blocked. And then I took everything to be blocked, and then I actually freed this area, right? And then I can continue doing this by hand. I can say, okay, this entry is maze 1-1. Maze 1-1 is also unblocked or free. So here maze, this is my maze 1-1 is gonna be M free. All right. What else? Maze 1-2, 1-3, maze 1-2, and maze 1-3 is gonna be free. And this is 1-1, 1-1, 1-2, 1-3, 1-4, 1-5, and 1-6. Maze 1-5 and maze 1-6. 1-6. Right. So you can continue doing this way, and I'm assuming that we can actually assume. Of course, we have 2 important things. This guy, this is which entry? 1, 2, 0, 1, 2, 3. 3 in the row, 3 in the first dimension, and 1, 0, 1, 2, 3. 3 in the second dimension should be M start, right? And then end, my end location is here. This is 0 in the first dimension and 0, 1, 2, 3, 4, 5, 6 in the second dimension. So M 0 to 6 is gonna be m end. The rest is filled. I need a little bit more, of course, here. Here I need more, but I can fill it. And this is a simple code that can actually fill this in, right? Fill this particular board with this. All right. So you can see that actually it is very tedious, right? This way is writing of this thing. And when I actually call this function from here, let's say I may start with an empty board like this. And then I can say call this function, this maze sample function, maze sample function with will fill it in. All right, so I have now a sample, one sample, in particular this. If I want to change, for example, the endpoint to be here, I can do that, or to be here. I can just say, if I want to make the endpoint to be here, so what do? I take my endpoint from 0, 6 to 1, 7, right? So I can go here and say, okay, this is 1 and 7 is my endpoint. All right, very nice. So this is, now we have shown you how to initialize a given thing like this. And we have also, so let's write a function to actually print this. So void print maze. So maze print. So I want to print my maze, and you recall that my maze is this way. Plus maze type, right? And I want to print this. How do I print it? So what I want to do is I want to print it maybe, let's say, as a empty, or let's say block for the first row. So that means that for, again, I would have the same thing as I had here. I need to go through this entire board once. So I will use this exact code segment here. I will go through the entire thing as we did before for tic-tac-toe. And I will start from row this, and I would print now, print f here. This, let's say this is an integer. I know that it is an integer. Something like this, perhaps. Right. So, of course, this is not the thing that I want to have. Why? Because this will actually print whatever the initialization actually happened here. So usually this will be 0, 1, 2, and 3 right here. So m blocked will be 0, m free will be 1, and so forth. So this will print something like for this board. For this board, it's gonna print 0, 0, 0, 0, 0, 0, 0, and is 3 and 0. And then 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, and then 1, 0, 1, 0, 1, 0, 1, 0, 0, and so forth. And then in this row here, it's gonna be 0. Of course, we have to have this printf here, of course. Printf, as we did before, we need to make a new line for each row. But I don't like to actually print those zeros and ones. I want to print, let's say for empty part, I want to print space, and then filled part, I want to print X, and for start, I want to print S, and for end, I want to print E. So one way to do this would be simply, I can actually have now a switch statement here, or my value here. This is my value. So for this one, case m blocked is simply I am printing an empty space. So I'm gonna be printing just a space, and I'm gonna be breaking here. So this is for the K blocked part. So if I am interested in free part, sorry, for free it is gonna be supposed to be this one, but for blocked it's gonna be this guy, right? And then for perhaps for the other two, for start, I'm gonna have an S, and for, let's say, end, I'm gonna have an E. This way now I will have an 8x8 matrix or table with some X's for blocked positions, some spaces for free positions, and an S for the starting position, and an N for the end position, and E for the end position. So this will be, you can see that one of the advantages of now using, let's say, this specific enumerated type is you can actually do this type of parameterization of names. And I don't need to care about anymore. I need to only know what it means here. And then I would actually just care about the values itself, the value names itself, not the values themselves. Are they zeros, ones, tens? I don't care. I only care about the value names. All right. Questions? Do you have any questions? All right. Are there any questions? Apparently no. Good. So let's do something more interesting with this thing. Let's say that actually, okay, what I want to do is I want to check if a move that I want to make. So assuming that I have this game, this board here, and initially I am going to be assuming that I am going to be at the location S, this start location, this red location, which is I already indicated here as this location. You can see that this is 3x3, row 3 and column 3. This is the start location. And I want to say, okay, let's actually I want to have a function that I want to move my position, start position, to one step down in this case. So I want to put it here. So I want to put my start position from here to here. So this is start position is where I am exactly. And I want to move it from here to here. Now, when I do this one, so simply let's look at what we want to do. We want to have a function. Let's say maze move down. I want to move down. I want to move one step down. If it is away, if it is doable, meaning if that space is actually empty, I can move, right? So this is what I want to do. And then what I want to do is once I actually done this one, my maze is going to become, let's say this is the starting maze. This in the third one is going to be, I'm going to have this guy to be, so what do I do here? So let's see, where is my table tool? So, okay. Let's make this white, and this is gonna be, then make this red. So after the move, so this is my starting one. After the move, I'm gonna be like this, if it is doable. Of course, in this case, it is doable, but if I were, let's say, here and I want to do down again, I'm not going to be able to do it because this cell here, the down cell, is not actually available. So what do we do? How do we do it? Ideally, if we want to actually do this one, and what I want to do is I want to return a value here, but I'm going to take care of this one later on. So down move means that I need to find where my start position is first of all. So I need to find, so what I need to do is I need to have a function that is something like this, maze find start. I want to find the start position and return it in my two return arguments here. So this is what I want to do. So I want to write a function called maze find start. It will find my start position and then it will return them in variables R and C, or arguments R and C. All right. So how do we do this one? It's very simple, right? We do the same thing here. We go through the entire thing. So we say, okay, initially we go through the entire thing, number of number, and we say if this guy is the start guy, right? Then I found it. Then I need to do something about it. So let's say that here we have SR is a start and ST is C is the end. Let's start assuming that they are initially not available. Then when I found my start position as start row is my row, current row, my start column is my current column. And perhaps what I'm going to do is now I can actually return this function. So SR and SC is going to return. Sorry, I should have actually done it this way. SR and SC. So I am returning my output, the find row and column in SR and SC. So I go through the entire rows, each row, and for each row, for each column, I'm checking if that row and column has an entry called mstart. If it is the case, then make my output variable, in this case, I'm gonna say that my output is initially nothing, and assuming that I will have something here, then I will actually do it this way. Now I am returning my row and column, found column and row number in my start row and start column, also SR and SC. So this way, this function finds the correct row and column number for the given maze for including the start position. And assuming that every maze has a start position, this will return a valid number. If there is no start position, then it will return -1 and -1. Okay, so this is fine. Then what I need here is essentially, I have, let's call an integer start column and start row. And what I will do is I will do my maze find start location, my maze, and my start column and my start row. Then I will just say SC SR is my start one. What I need to do is I need to change this one. If I was at a start row and column, a start cell, I can make this one cell, and when I move it, I can make it free because I'm going to move to the down one. And then, so how do I actually move down here? So what do I do? How do I change it so that now my start position move to from the current location to the next location? So I need to do something here and something here. So what is the thing that I need to do here to, assuming that it is empty, what do I do? How do I change these entries and move my start position from one up to down? So from here to here, from here to here. So a C++, all right? So what you are saying is that you do a C++ here. And SR, so look at this one. So this is the row number. So 0, 1, 2, 3, 4. Row is 4 and column is 4 as well. 0, 1, 2, 3, 0, 1, 2, 3, sorry. 3 and 4, 4 and 3. So 4 is the row number. No, so this one. 3 is the row number and 3 is the column number. All right. So you are suggesting that we increase the SC, the column number. But column number is increasing would put me somewhere here. You see that, right? Somewhere here, because you are increasing the column number, or at least you are intending to increase. It's not going to work either, but anyway, we'll see that. What you want to do is you want to actually increase the row number, because this way, so row numbers go this way from top to bottom, column numbers go from left to right, right? So I need to actually, instead of doing a C++, I would actually do this. So this is ideally what I need to do. But there is a problem with this one. I cannot do this one. If you recall, an post increment operator takes the number in SR, returns it. So SR is 4, no, 3 in this case. It will return a 3. It will be used, and then once it is used, it's gonna be actually incremented. So in this particular case, what I am gonna be doing is actually, I am gonna be doing the same row as I have here. It's gonna change the third row, not the fourth row. So what I need to do here is, I need to do something like this, SR plus 1. So go to the next one in the row. So going down, in this case, going down means increment the row number by 1. Of course, this is only possible if this row, this guy, is empty. If it is not empty, then what do? I cannot move. So first of all, if this guy needs to be empty, how do I check it? Empty and free, sorry. So if this guy is free, then I can change the current row to be free because I am moving away from it, and the next row to be filled, or my start position now, right? So what I did is, I was here, this is 3 and 3. So this is 3, 3, right? So let's make it smaller so that we can fit in my number here. So this is 3 and 3, and this is 3 and 4 and 3. So I want to make this one to be empty or free, and this one to be my now start position, because I moved my start position to the next one. All right. So if it is not the case, then what am I going to do? I'm going to say, okay, I cannot do it. So perhaps I want to have success here, successful move, or success. Initially, I am assuming that I am successful, or I am not successful. And then I will actually say, if I am able to do this one, I will make my success to be 1, and I want to return that. Yes. So that the caller is going to know that, yes, the move was successful and it was done. It was done, moved 1. Okay. But what if, so there is there any question here? Okay. So satırın sayısını artırmamız lazım ama dizinin 2 boyutunu artırıyorsunuz. İkinci boyutunu mu artırıyorum? Do I do it that way? Oh yeah, you are right. I'm making this wrong. Perfect. I need to have the column entry here, the row entry here, if I want to do this right. This is the first one is the row. This is how I defined it. Good catch. The second row. Second entry is the column. First entry is the row. All right. So good. Any other questions? Of course, then this is fine. Now, did I do anything wrong here? No, these are fine. Any other questions? Evet, dıştaki for row number oluyor. Arkadaşlar onu uyardılar. That's good. Now, but there is one more problem here that I need to take care of. What if this row is actually a blue row, meaning an end row? So in that case, I can actually, now what I will do is I will reach the end. Perhaps I need to actually say something here. I need to perhaps either say, okay, if you want to actually do a down move first, you check it. If this is an end, then you are done. A down move would mean actually that you are successful. So This means that this is actually, when I actually change this one free and then move to the next one, I may lose my end label. So perhaps what I can do is I can say, okay, the success is actually initially -1. Okay, you can say here returns -1 if move is not doable. Move cannot be done. Returns, let's say 1 if move is done. Returns, perhaps let's say returns 2 if end it has been reached. So then I need to actually do one more thing here. Here, what I do is, now if I say this guy, this next guy, before actually doing this one, I need to say before changing this to start, I say if this guy is end, if I reach the end, then I will do success is gonna be 2 because I am done. I wanna say that I am done. I have actually found the output or found the endpoint, or else I would actually just say that I have moved successfully out of there. Right. So this way now, move down function actually let me help, or let me actually handle two cases. One is if there is no movement possible, meaning down movement is blocked by a blocked cell, then I don't do the move. If it is doable, if it's not blocked one, then I can either have a free cell. If it is a free cell, then I will just move and return 1 as success output. Otherwise, I will actually, if it is an end one, I have reached the end, I move to the end, and I am done. My end and start now is the same thing. All right. So this is good. So let's actually simply do this one for a left movement. So let me know if I want to do a right movement. Sorry, let's say move right. So what am I gonna change here to make this movement to right? So I'm waiting for your response here. So let's see here. The original code was doing a down movement. Now what I wanna do is I wanna do a left movement. Tell me which line of code will change here and how. I'm waiting. Which line? First of all, which line, which part of the code? Type it properly. So SR -1. Someone say, Hussein Ömer said SR -1. Let's see. If I do SR -1, let's look at from here. So what did I want to do? I want to try to move here, right? I want to try to move here to the right. We said right? Yes. Move right. I want to move from here to here. From here to here. So that means that I'm going to keep my row number the same, but I'm going to change my column number. How am I going to change my column number? By incrementing by 1. So row number should stay the same. Row number should stay the same. And column number should just change. Right? Anybody thinking differently? You should wake up, people. I'm asking a question. We have another 10 minutes or so to go on. So any comments or any questions? So what I am doing is, since if I am trying to move to the right from here to here, I will check if the right cell is empty, meaning I will check for row and column. I will check the same row, but just one column more to the right. So this is what I'm going to check. And if that check is correct, then I'm gonna make it free. No, actually, we did a mistake here. We should have done it. So this is fine. I'm gonna make if this is free, in this case, it's not gonna be free, but assuming that it is free, then I am gonna be doing this thing. And I am gonna be doing this guy here. So instead of moving the row by increasing the row number by 1, I'm gonna go down. Instead of going down, I'm gonna go right. I'm gonna increase my column number just 1 by 1. In that case, if I ask you to, let's say, move to the left, what are you gonna do? Left now. To the left. SC -1, exactly. Row is gonna stay the same. People, your answer, this SC post decrement is not gonna work. You have to be careful. If I actually do it this way, I'm gonna have a trouble here. If I do it this way, like this, or like this is not gonna work, because this is gonna actually look for the same column first and then increment it. Perhaps you can do a post decrement, like a pre-decrement like this, or increment, then it will work. Okay, but it's easier to actually do it this way. Now, going to the left would mean that I just actually do this. Okay, in the same case, if I want to do actually up, if I want to go up, I'm gonna just decrement this one by 1. So I'm gonna just say SR -1, and here SR -1, and here SR -1, of course. All right. So, which means that actually I can combine these functions into one. Let's actually combine them into one function. All of these. Move. I'm gonna do a move. I'm gonna actually give you a parameter here. Movement, let's say call this character move direction. And move direction can be left, right, top or bottom, or up and down. So let's do it this way. I would find the same thing here. And depending on, so I will have the current SC, current SR. So these are, and then I will have next SC and next SR. Then I'll have a simple switch statement for move direction. And I say, okay, if move direction is case left, I know that my next SC is gonna be what? And let's do it this way. I'm gonna have my next SC something, my next SR column. Let's do it this way. First column first and then row second. Then this way. And then if, and there is gonna be a break here. And then there are 4 cases I have. The first case, the second case, third case, and the fourth case, and there is no other cases available. So left, let's say right, this, and up or down. So what I want to do is I want to make my, now this is my next one, next SR, next row and next column. If it is free, then my previous column and previous thing is going to be free, and my next row and next column is going to be my end, and I'm going to do this guy here. So I'm just actually changing, keeping my next column, next row and next column in 2 variables, and I want to change them here. So for left movement, what is going to be my next row? For a left movement and a right movement, my row is not going to change. So it's going to be current row. right? But my column is gonna change. Column is gonna change such that it's gonna be -1 to the left. To the right, it's gonna be +1. Or the same thing for up and down. My column number is not gonna change. Sorry, I did it wrong. Sorry. So my column number is not gonna change for left and right. No, this is correct. Sorry. Now for up and down, my column number is not gonna change, but my my row number is gonna change. No, for down movement, I'm gonna have a next row by adding it, or I'm gonna have the next previous row by adding it this way. All right. Now this is now taking care of quite a few different things. You can see that now I'm deciding for a given left or right or up and down movement, which column should I check and which column and which row. And then depending on those decisions, I make this thing here. So this is fine. All right, so I don't need to have this move down and other things. Instead, I have this maze move function, which is parameterized by this direction movement. And I am actually checking every possibility. Of course, there is one little problem here. What if I am in the beginning, I am here? Assume that in the beginning, let's do it this way. This is not the place that I am. In the beginning, let's say that I am here. There is nothing saying that I cannot be this way, right? So what if I am here and I want to do a up movement? I want to move up, right? So this is 0th row, so row 0. And what column? 1, 0, 1, 2, 3, 4, 5 column 5. So if I call this function with an up movement, it will actually try to decrement this by 1, which will actually try to go for this place here, which is not existing. There is a place here. So it's gonna go for -1. But -1 is not existing here. There is no such thing. So what needs to happen is that I need to make sure that the result of any of these numbers are not negative, or if I was here, for example, at the very end, a down movement, or I was here, a right movement, or I was here, a left movement is not supposed to happen. So what I need to do is, if I'm not just gonna check this guy, but also I need to check this thing. I need to make sure that the next SR is not less than 0. This has to be the case. If it is less than 0, so what do I do? If this is the true, and this has to be less than or greater than or equal to 0, and next S row should be also less than num rows, and next column should be greater than 0, and next column should be less than num columns. This way now I can be sure that this is gonna actually happen. And one of the problem is that still this is a problematic because this check is gonna fail. So I need to put this check very end of the thing here so that when they fail, when this fail, one of these fails, I'm never gonna actually, this is short circuit expression, logical expression. So I'm not gonna get into here at all. So otherwise, I would reach -1 here, or larger number than number of columns or number of rows -1. So this has to be very, very careful. So you would make this type of an error when you actually try to access an array with a negative entry as an index, or an entry that is larger than your allowed or your declared number of entries for the dimension that you are actually defining. Any questions? Any questions? So we are out of time. We'll continue with this thing tomorrow at the same time at 1:30 again. So you all have a nice day and stay safe inside. All right. See you later.